Hello guys, welcome back to our channel. This is my second session in this series and I hope you people remember that I have taken the session 1 for NEET 2021. In my first session I have explained you that what we are trying to achieve in this particular series of 5 sessions, and in session 1 I have discussed that how you people can score a decent marks in NEET 2021. So there are some selected topic which I have given to you. I hope you people have seen that particular slide and you have saved it somewhere. But you need to understand that when we start with session 2, you people have also go through the session 1. So you people should have a clear picture that what strategy we are going to adopt. In my very first session, I have taken topics from mechanics where we have seen that how different numericals can be approached and how we can solve. So my point here which I am trying to explain you that when you have a questions in front of you, whenever you have any numerical or a conceptual question in front of you, how you people have to think so that you should be able to correct that question, so that you should be able to solve that question correctly. Now, in my second session, I have taken the unit electrostatic, and you people are aware that electrostatic is actually one particular unit which consists of 2 chapters, which is electric charge and electric field, and electric potential and capacitance, which is part of your grade 12th syllabus. Okay. Now, without wasting any time, let's move on to the question and let's see that how we have to solve specific question in this particular unit. Okay. Now, when I go for the very first question which I have over here, I'll read it for you and I will tell you that how you people have to think about this question. A charge Q is enclosed by a Gaussian spherical surface of radius r. So first of all, you people need to know that what exactly this Gaussian spherical surface is, and for that you need to have a knowledge of Gaussian theorem. It says if the radius is double, then the outward electric flux will be doubled, increased, reduced, or remain the same. Now if you people remember when we talk about electric flux, because the question is about electric flux, I think the formula which can come to your mind that electric flux is number of electric field line passing through an area. This is the basic definition of electric flux we have, and when we talk about Gaussian theorem, it has been given as that enclosed integral E dot dA is equal to charge enclosed by epsilon naught. This is basically a conceptual question. What you need to know that when you consider a charge and when you have to calculate the electric flux of this charge, the Gauss said that you can draw a Gaussian surface around it. When I draw a Gaussian surface, you need to understand one thing. There is no specific radius is given for this particular Gaussian surface. Gauss said that it should be enclosed. That means the charge should be enclosed inside this Gaussian surface. So no matter how big I draw this particular circle to ensure that my charge should be closed inside, I think all 3 Gaussian surfaces are absolutely correct. But if you look at the radius, this is R1, this is R2 and this is R3. What we need to understand that the charge which has been trapped inside the Gaussian surface, it is same. It is not changing. Until the time this enclosed charge is not going to be changed, your electric flux value is also not going to be changed, because electric flux according to Gaussian theorem can also be calculated by this way, and if my internal charge is not changing, no matter how big or how small you draw your enclosed surface, the value of electric field line passing through the area is not going to be changed. Okay, definitely for a smaller circle you can visualize the electric field will be much closer, and when you keep on moving away from this charge, the electric field line space will increase, but the electric field line which are passing from the first circle, second circle, third circle will remain the same. So without any doubt, I think the correct answer for this particular question is going to be remain the same. Yeah, rest all the option will be wrong. So this is the one particular option which appears to be correct to me. Okay. After doing this particular question, let's move on to the next question. So here we have the next question which says the electric field E at a point just outside a perfect conductor is. parallel to the surface, 0, perpendicular to the surface can have any direction. Now you need to understand, this is one very important concept over here we are discussing about. Basically, I need to know the relation between electric field and the conductor, because whenever you people visualize the electric field, we know that electric field is something which always goes from positive to negative. So if I actually visualize my positive and negative charge on both the side, I would be able to see that my electric field originates from the positive charge and it is moving towards the negative charge. So whenever you have to draw electric field, I would suggest you should always able to visualize these charges which are present across. Now when we talk about when you place a conductor, now you need to understand what will happen in case if I place a conductor. Because placing a conductor, what is going to be happen? A conductor which is having n number of free charges. So there are a lot of free electrons which are moving in the conductor. So what will happen? The electric field will find the positive, will find some of the negative charges on the surface of conductor. So you can see that some of the negative charges are going to be present here, and similarly your positive charges will be here. So what basically is happening is inside the conductor you have isolated or you have separated the positive and negative charge which is present inside the conductor. And because of that, what will happen? You have electric field present not only outside, but you also have an electric field which is present inside the conductor. And definitely electric field always goes from positive to negative. So you can see that this is how the electric field is going to be appear. One very valuable important point which I am going to give you, and remember this information, and this piece of information is that you have a combination of electric field, one is outside, one is inside, and because of that the net electric field which you will have over here is going to be 0. So the net electric field, as the two electric fields are in the opposite direction, the net electric field inside the conductor is going to be 0. This is one particular thing which we need to remember. And because of that, what will happen? This electric field which is present outside, it is going to be get modified, otherwise you won't be able to explain one particular concept over here. My point here is your electric field will be modified in such a manner that you can actually see that your electric field line everywhere it appears to be perpendicular to the surface, and for that I will tell you that why it should be perpendicular after modification. For that you need to understand, in this way whenever the electric field is perpendicular, there will be no component you can draw on the surface of a conductor. Like if electric field is perpendicular everywhere, I don't think we need to resolve and we will get any parallel component of electric field with the conductor, because the point here which you need to understand that electric field component cannot exist on the surface of a conductor. The reason for that is what? If electric field component exists on the conductor, because of that what will happen? Your charge will start accelerating, and if charge will start accelerating means you will never get a charge in state of rest or in equilibrium state on this particular conductor, because it will keep on moving, which is not going to be happen. Yeah, because your conductor, whenever you are going to store any charge on it, it is going to be state in an equilibrium state, it will not move. But as if you draw a parallel or if you draw any component of electric field with the surface, then you won't be able to explain that why these charges are stationary. Okay, so for that reason the stationary charges which you have, if you have to explain that how it is stationary or in a state of equilibrium, that is possible only when your electric field is in contact with the conductor and it is perpendicular to it. So there is no reason to resolve, there is no way you can get parallel and perpendicular component of electric field with the conductor. So here in this case I think we can perfectly predict. Now it says electric field at point A just outside the perfect conductor is perpendicular to the surface. So my correct option which I have over here is option number C, and for that I have explained you in detail that what is going to be happen in case if you place a conductor inside a electric field. So the initial electric field which you people have seen in the beginning, it gets modified. Yeah, valuable concept in case of electrostatic. So remember it. Now let's move on to the next question. Okay. Here in this case, the question 3 says, which of the following graph shows the variation of electric field E due to a hollow spherical conductor of radius capital R as a function of distance from the center of the sphere. Now what you need to understand over here is this: when I am going to draw my hollow sphere, okay, definitely there will be some type of charge which is going to be present on this, but we need to understand when we draw the graph. So I am drawing my x-axis and y-axis over here. Be very careful, all three graph has been given with electric field and position small r, okay, electric field and position r. I hope you can see that now. What we need to understand that when you are calculating electric field inside the sphere, because this is where the capital R will be, but inside the sphere the electric field, I have just showed you that inside the sphere the electric field is going to be 0. Yeah. So what is going to be happen till the time you reach the surface of the sphere? The formula for electric field is kq by r square. So you people can observe inside it is not possible. So that means till the time you reach this particular value over here, which is the surface of the sphere, here at this point your electric field is going to be maximum, because this is how it has been derived, or this is how it has been calculated. E equal to kq by r square, where k stand for 1 by 4 pi epsilon naught. But after that, if you see what will happen in case if your position from the center keep on increasing, then you can see that your electric field is having a relation with the position which says that electric field is inversely proportional to 1 by r square. That means after that point the electric field is going to be decrease. Yeah, because it's an inverse relation and it's a square, so exponentially decreasing. So you can notice that your graph which you will draw from the surface is going to be go in this particular way. So when we actually look at the option over here which is given to us, what we can see, option A over here is the one which look like similar to the graph which I have drawn over here. Rest all the option you can see there is some kind of a electric field has been shown inside the spherical shell. So absolutely these answer cannot be correct. The only correct option which we have over here is option number A. Yeah, I hope you are clear with this particular concept, because you can see there are a lot of questions in entrance which are based on this concept of electric field. Yeah, let's move on to the next question and see that how we need to approach the next question. Okay. When I read the next question over here, what you need to understand that this question definitely, it looked like a question on a dipole. So 2-point charges, positive q and minus q, because we know the definition of a dipole. So if you people can recall anything related to the dipole, it will be good for you, because somehow you would be able to relate those things over here. Plus q and minus q are held fixed at minus d0 and d0, respectively of a xy coordinate system. What we will do, we will draw a rough diagram for it, because you can see the x coordinate which has been given. So even if I draw my x axis over here, let's say if this is the origin O, at this point I can say it is minus g somewhere here and this is plus g. What I am going to do, I am going to imagine the two charges, one is positive q and the other is negative q, has been placed at these two particular points. Now we will read the option, because we need to select the correct option over here. And when we are going to deal with the option, we need to be very careful, because this is one particular concept which we have to use over here. But we will justify even if there are other options why they are wrong. So even if we get the correct answer, we will see that why the other options cannot be correct. Let's read the option number 1. It says, your electric field at all points on the y-axis is along I cap. Okay. Now for that, what you need to do, you need to visualize the electric field. I'm going to draw it over here because this is something which you should imagine, okay? So you should not waste time in it. So when I see, I just want you people to visualize with me, when I see the point charge plus q, I can see its electric field look like radially outward to me. So above the x-axis I have shown the electric field which is going to be appear from positive charge, because positive electric field is radially outward. So you can see at every single point the electric field is going away from the charge. When I visualize the electric field of a negative charge is something which is radially inward. So what I can see that everywhere that arrows which I am drawing, they are coming towards my negative q. So this is the way I should be able to visualize the electric field first. Now what we need to do, now I want you people to see very carefully, if I divide this whole thing into 3 regions, this is my region 1, where you can see the 2 electric field are in the opposite direction. In region 2 they are in the same direction, and region 3 they are in the opposite direction. It says electric field at all point on the y-axis, okay? I have no problem, because when you people visualize your y-axis, you can draw your y-axis over here, so that you should be able to justify the x you have already drawn, and this is the y-axis which I have drawn over here. The question here is, electric field at all point on y-axis is along I cap. I have no problem. At the center I can see the red arrow and green arrow both are in the same direction, which indicate that this electric field over here is definitely along I cap. So electric field at the center is definitely look like that it is moving towards the positive x-axis, which is positive I cap. But in case someone is wondering what will happen in case if I take some point on the equatorial, for that you need to understand that even if you draw the electric field at this point will look like this, positive radially outward. For negative charge, if you visualize the electric field, it will look like radially inward. So at this point P, I have drawn the electric field due to positive charge, electric field due to negative charge. What I can see, I don't have to calculate it completely, what I can see that here the 2 charges, the net electric field will definitely come over here, because when I draw the parallelogram, my diagonal is going to indicate the direction of electric field at that particular point P, which is also going along the x-axis. So I can say that electric field over here is also going along positive x-axis, which is I cap. What you need to understand that point A, which is written E at all point on the y-axis is along I cap, it's look absolutely correct to me, because even I have tried a point on the x-axis, even if I try any point on the y-axis, I can see that electric field is actually along the positive x-axis. So I will mark this particular option, which is absolutely correct to me, but we will also see the other 3 options which has been given, whether they are correct or not. B, option number B says, electric field E at all point on x-axis has the same direction, which I can simply see no, it is not possible, because I have seen that electric field here are in the opposite direction. So they are not in the same direction, so which option is absolutely wrong. The dipole moment 2qd directed along I cap. Now this is one more information which you need to have, guys, because I think electric dipole moment is always something which is given, that electric dipole moment direction is from negative charge to positive charge, and you can see your negative q is present here and your positive q is here, so your electric dipole moment direction is negative I cap. So this is also wrong. Work has to be done in bringing a test charge from infinity to the origin. Now this is one particular option where you might get confused, because this is a question about work done. Now one thing which you need to understand when we talk about work done, I think the formula is the work done can be calculated by change in potential multiplied by charge. This is what the formula for work done is. Now when you see this particular option over here, that work has to be done in bringing. Now look here, when you talk about infinity, the potential at infinity is 0. When you talk about the origin of the dipole, the center, you need to understand at the center. When the two opposite charges are present, the potential at the center is also going to be 0. So that means you are going to move a charge from 0 potential to 0 potential. That means your change in potential which you have over here, it is also going to be 0. So no matter if you move a charge q, whatever the value of that charge q is, if the change in potential is not there, your work done will not be there. So your work done will also be 0 in this particular case. So what you need to understand that this option is also wrong. So the very first option which we have read and we have proved, that is the only option look correct to me. And when I see this particular question, I will definitely say for question number 4, our option A is absolutely correct. Yeah? Okay. Now let's move on to the next question. Here we have a question which says, this is my question number 5. A metallic shell has a point charge q kept inside its cavity. Which one of the following diagram correctly represent the electric lines of force? Now, one thing which you need to understand, first of all, whichever option you can discard it first. And definitely I can discard one particular option, or I can say two particular options simply at looking at the diagram, because my charge, if it is exactly at the center, my electric field lines are going to be appear radially outward, and definitely with the surface also they will have interaction that it will be perpendicular to it. But as charge has been not kept exactly at the center, see, this is what the exact center of this particular shell is. So charge has been shifted from the center. So the diagram which appears to be straight electric field line, simply ignore those options. Mean those options are no way that can be your correct answer. Now the option number C and option number D, when you actually see, both appears to be same to me, but you need to understand one particular thing, that when we talk about electric field inside a shell is written as 0. Definitely they are making 90-degree angle wherever they are making contact with the shell. So that is one thing which they have done correctly. But if you observe in one particular option what they have done, they have actually shown you electric field lines traveling inside. But we know that electric field line can never exist, okay, because that combination of electric field is in such a way that the electric field inside the shell is 0. So what we need to understand, this particular part where they have drawn the electric field line inside the shell is not correct. Yeah, so what we need to do, we will discard this. The correct option which we have for this question number 5 is going to be my option C. I hope you people are clear till now. There are similar kind of a concept which we are talking about, and this is one thing which you need to understand when it comes to question based on electrostatic. Yeah? Okay guys. Now let's move on to our next question. Our next question which we have over here is question number 6, which says, an electron enters in an electric field with its velocity in the direction of electric line of force, then there are multiple options which is given to you, but what you need to do first, you will simply visualize your electric field. There is no harm in imagining electric field line, and when I show you that electric field line, I told you the moment you see electric field line, you also have to visualize the charges which are present on the either side. As electric field goes from positive to negative, I can see this is how the electric field line can be drawn. Now look here, now let's attack the requirement which we have over here. Electron enters an electric field with its velocity in the direction of electric field line. So this electron which I am going to draw, it enters with some speed along the electric field line, but the moment you see electron means negative, and negative means something which is definitely going to be repelled by the other side, because other side also consists of electrons. So what is going to be happen? Similar charges, they are going to be repelled, means definitely the electron which has been projected with some speed, its speed is going to be decrease. correct? Now one thing which you need to understand here, the option 1 and option 2, circle, parabola, these things happens only when you have magnetic field present. So this is a question about electric field. So whatever changes are going to be happen, they are going to be happen according to the translatory motion. So whatever the changes you have going to comment, you are going to comment on the linear motion of that particular electron. So what we can say in option number C and D, if we have to choose one, we will say the velocity of the electron will decrease. So I am going to go with this option which looks correct to me. Yeah. So again, a concept of electric field, and we are able to solve this particular question by that particular concept. Okay. Now we have solved somewhere around 6 questions. I hope the electric field, most of the questions which are going to become in the exam, you would be able to relate. Don't expect a similar kind of a question. Don't expect exact same question, but you can expect a similar kind of a question. That's the reason I'm not only targeting the one particular solution which we have, even I'm trying to explain you why the other option will be wrong. Okay. Now guys, this is our next question, which is question number 7. It says the spatial distribution of electric field due to two charges AB is shown in figure. Which one of the following statement is correct? Okay. Now when you see this particular diagram, the very first thing which you should be able to relate, that A is a charge from where the electric field line appears to be emerged. So this is my positive charge, and here my electric field line are going to be radially inward, which is my negative charge. I have assigned the charges nature, positive, negative. So in whichever case they are saying both are positive, both are negative, forget about these options, because these options are actually, you can discard the moment you see the diagram. Now in A and B, both says A is positive, B is negative, A is positive, B is negative, and now we have to give the relation whether that A is equal to B or A is greater than B. What you need to understand over here, when you talk about a charge, positive charge electric field is radially outward. But at the same time, if I draw one more positive charge, and you can see or you can visualize that electric field for this first charge A, if I have drawn 4 lines and I say this is Q, if you are going to increase the number of lines, what does it indicate? It indicates it is the same nature charge, but the magnitude of this charge is more. As the electric field lines are doubled, definitely its magnitude should be 2 times of the previous one. So if you have to answer this particular question, what you can do, guys? If I calculate my electric field lines for A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And if I calculate my electric field line for charge B, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can see that the number of electric field line which has been drawn on the 2 charges is different. So the one which is going to have more number of lines associated with S, you can simply say that charge is actually bigger in magnitude. So this is one particular condition which looks absolutely correct to me. So your option A is absolutely correct. Yeah, this is my question 7. Again, the concept of electric field. So there are some minute details which I am trying to give you over here, so that you should be able to reach to the correct conclusion of that particular question. Okay. Now guys, let's move on to the next question over here. The next question is about work done, because I can see all 4 options is talking about the work done. The question says, if a unit positive charge is taken from one point to another over an equipotential surface, then, okay. First of all, you need to understand the definition of equipotential surface, which I hope you people are already aware that equipotential is a surface where the potential is going to be remain same. Okay. In that case, what we need to understand that if you move a charge on equipotential surface, if we talk about the, let me show you, if I say this is my electric field lines, I know many of you can directly comment on the answer, but there is something which I want you to visualize. Electric field, if you draw plane, parallel, vertical, plane like this, these are the equipotential surface which can present inside an electric field. And if you say the potential of first plate is V1, this is V2, this is V3. Here the question says if you move a charge on an equipotential surface, that means I have taken a charge on plate 1 at some point A and then I have moved it to some other point B. But it is on the same plate, the displacement has been happened. So what we can say that work done value is calculated by change in potential multiplied by charge, and my point here is as the potential at point B and the potential at point A, it is going to be remain same because this is a concept of equipotential. The potential value cannot be different at these two particular points. So what we can say that my potential difference is going to come 0, and when my potential difference is going to come 0, that means there is no potential difference. That means the work done value is going to be 0. There are a lot of questions which you can expect on this particular concept of work done. So here in this case you can say that there is no work done. Yeah, I hope you people are clear with this particular question. Now let's move on to the next question in this session. Okay. Question number 9 says in the following diagram the work done in moving a point charge from point P to point A, B, C is respectively as WA, WB and WC. Now when I look at the question from point P, let's try to visualize something. From point P they have work done in moving a point charge. You can assume any charge over here to point A, B and C. So I have taken it from A, then B and then C. So there are 3 different points which has been shown, which I can show you over here. Definitely it is a question of work done which comes under electrostatics, so we don't have to relate it with the formula which we have learned in mechanics, which is work done is equal to force into displacement. Forget about that. Think about a formula which is in electrostatic, which we know that change in potential multiplied by the charge. Now when it comes to the change in potential, here you people can't visualize any other charge which has been present. That means I am simply taking a charge from some place and I am moving that charge in the space where there is no other electric field line is present. If you are doing something, okay, if you are moving a charge and there is no electric field which is present, let it be going along or against, there is no electric field line is present, that time you will say that the work done by you to point A and B and C is going to be same. So when you read the option, definitely C and D you can remove. Now the question is A and B, which one should be correct? In A and B and C you need to understand that work done when you are going to do, when you take the point to A or when you take it to the point B or when you take it to the point C. In all 3 cases you are not doing work against any electric field line, okay, or not even along the electric field line, because you can't see any other charge which is present except the charge which is present at point P. So what we will say that in this scenario the work done which is going to be happen, it is going to be 0, which look like the correct option with B, and that is what is going to be your answer. Straightway you people can relate with this particular part and try to understand that how we are calculating work done in electrostatic and how we can actually relate with it. Okay, it's important to understand this particular concept of work done, which I'm trying to explain over here. Okay, let's move ahead. Let's see the next question. The next question is about a hollow metal sphere of radius 5 cm is charged so that the potential on its surface is 10 volt. Okay, let me draw a hollow sphere. It has been charged, so there is 10 voltage potential present on it. At the center of sphere is, now the question is about at the center of sphere is, what is going to be happen to the center of the sphere? It says center of sphere, the value 0 volt, 10 volt, same as at 0.5 centimeter away, same as 0.25 centimeter away from the surface. There is one very valuable relation which you people have learned, the relation between electric field and the potential. So when I write electric field and potential are related as E equal to dV by dr. This particular relation of electric field and potential is going to give you the answer. But the point here is how you people can crack that particular concept. Now there is one thing which I hope you people are very clear, that when we talk about a hollow sphere, I have showed you in the very first question, second or third question, that electric field, whenever a conductor has been placed, the electric field inside a conductor is going to be 0, because there is a separation of charges and the net electric field is 0. So that is all those things which we have considered over there. So electric field is something which I know. What you need to understand, that electric field equal to dV by dr, and this electric field is no doubt, I am very sure that it is going to be 0. Now if you people have a basic knowledge of differentiation also, that is dV by dr which is written, which look like a differentiation of voltage with respect to position, I can say one thing, that this d by dr differentiation of voltage with respect to position and this V value, what should be this V value so that my electric field should be 0? Your V value, as you people have learned, should be constant. That is the only way you can say that differentiating a constant always give you a 0. So what I need to understand, okay, at the center means the value is going to be constant. So let me tell you, this is examiner asked you specifically at the center, but even if you take any point in the hollow sphere, no matter where, center or anywhere, the potential value is going to be constant, and it will be exactly same as the potential value which you have on the surface. Correct? So in this question, the correct option appears to be this, and you can mark option number B. One more thing I will tell you which you need to understand over here, if a question comes about the work done also, like if someone says what will be the work done if a charge has been moved above the surface to any point inside the surface, in that particular case, I think you know the answer. Because if potential at two different points is going to be same, and if you see the formula, that work done is change in potential multiplied by charge, what is going to be happen? The potential difference will not exist between A and B, because both have the same potential value. So in that case also your work done is going to be 0. So remember this particular question, it can be asked for potential, it can also be asked for work done, but you should be able to relate with the concept. Yeah, because if once the concept is clear in your head, definitely you can easily approach this particular question and you can get the correct answer. Okay, I hope I have done 10 questions till now, and every single question is clear to you. If there's any doubt you have, you people can post in the chat and we can discuss more about it. Yeah, let's move to the next part. Now when we see the next question in this particular unit of electrostatic, question says figure shows 3 points A, B and C in a region of uniform electric field E. The line AB is perpendicular and BC is parallel to the field line. Then which of the following holds good, where VA, VB, VC represent the electric potential at point ABC respectively. Question is about electric potential. Now what you need to understand, again, I hope you people remember that electric field relation which I have written dV by dr, you people remember that. To be very precise, you also have a negative sign over here. That negative sign simply tells you that your electric field line always travel from high potential region to a low potential region, or you can say positive to negative, because we know that about electric field. So positive is nothing, it is high potential, the negative is nothing, it is a low potential. You should be able to visualize that how we can visualize the potential for this electric field line. Electric field potential. What we can do, I have shown you that if you wanted to visualize the potential, the same potential, you can draw vertical parallel planes which actually tell you that on this plates your potential value is going to be same. Correct? So everywhere on this plate, if you take any point, the potential value is going to be same. So if you are saying that here the potential is V1, this is V2 and so on, let's say this is V5, okay. I can simply see one particular thing, that point A and B are both the points present on the same plate, which simply tells me what? It tells me that my potential for A and B is going to be remain same. So what I am going to do, I am simply going to discard the option where the A and B is having given different potential. Okay. You can also discard because the C is something which is not on the same plane. So this option is also looks wrong to me because C is not the point which is present on the same plate which I have drawn over there, because that is my equipotential plate present inside the electric field. Now if you people see that there are two things which we need to identify. Basically there are two options in which we have to identify that which one is correct. My point C, which I can see over here, it is present and I have written that it should be V5. Now what I told you, potential is something which you can relate with electric field. Wherever the electric field line is traveling, the potential is decreasing, which is actually told by this particular sign. Wherever the electric field lines is traveling, your potential is decreasing. That means the potential which you are going to get at point C and the potential which you have for point A and B, which I have written V2, the value of potential at point, let's say this is potential at B, potential at C, this VB potential should be more than the potential at C, because my second plate, which is AB, present very close to positive charge and the plate C is present far away. So definitely for that particular plate your potential is going to be high. So if I have to select the correct option, my correct option is that VA and VB are the correct, the option number B is the correct option because VA and VB are same and this particular potential is more in value when you compare it with VC. Yeah, so this is how we need to do this particular question and I hope the concept is clear to you. Yeah, now let's move to the next question over here. The next question says, the figure gives the electric potential V as a function of distance through 5 regions on x-axis. Okay, which of the following is true for the electric field E in these regions? So you can see electric field graph has been given for region 1, region 2, region 3 and this is region 4 and 5 also. Okay. One thing, you should be able to relate potential and electric field, because in this question the graph which has been drawn, it has drawn for the potential and the relation which we have to give for electric field. Okay, not a problem. We know that wherever the potential value is constant, there are 3 regions which I can see that my potential is constant. Wherever my potential is constant, that means at that particular place my electric field will be 0, or you can say electric field will be same. So in this case I will first select the option which have E1, E3 and E5 given same to me and I can figure out this is the only place which has been given over here. This is E2, E4 and E5. E2 definitely not possible over here. This option cannot be correct. So E4 also is okay. Let me tell you one more thing. We have solved that option B is correct, but how you people can see that E2 is less than E4? Because slope of this graph, if you look at the electric field relation, dV by dr is nothing. You can also say it is actually a slope. That means slope of second and fourth line, if you take, that is basically going to give you the value of electric field. What you need to understand that whichever slope, wherever the value of theta appears to be steeper, that particular value should be more, because slope is something which you can also mention in terms of tan theta. So wherever the bigger value of theta you can assume, that is one particular value which you can say it is more. So I can see that my E4 is much steeper compared to E2. That is the reason they have given this relation that E4 should be greater than E2, which is also absolutely correct. Yeah? So I hope till now a lot of conceptual questions we have done on electrostatic, and every single relation which we can give, there is a very most important formula which appears to be is the relation between electric field and voltage. So I hope you people are all aware about this particular relation, and if someone still wanted to wonder that what exactly it is a relation of electric field and voltage, and this negative sign is actually the relation which has been given between electric field and voltage. Wherever the electric field lines are traveling, your potential will always decrease. So if you have 100 volt over here, it should be 0 volt. This is the way you can also imagine. Yeah? So there are a lot of questions which are based on this concept. Let's move on to the next question, guys. Okay. Moving on the next question, okay, it says find the following value of given capacitor of area A and separation D. Okay. So there is area of the capacitor plate has been given and the separation is given. We need to calculate the C equivalent and K equivalent. Okay. See, examiner can ask you any question, but here in this case I am going to tell you that how you people have to approach this type of question, because you have seen parallel plate capacitor, okay, and parallel plate capacitor, when we write the formula, the capacitance can be written as epsilon naught A over D. So this is the general formula which comes to my mind, okay. But how we need to understand in this particular case what we can do, you people can first you can consider, okay, for me it appears to be 3 capacitor, because this is C1, this is one particular C2, and this is C3. C1 and C3 in which you can say there is no medium is present, which is basically air, and for C2 capacitor they have inserted some dielectric, which is value is given as K. How we can calculate the C equivalent? So I will tell you that how you can make this question very easy and you can solve this particular part. So what you can do, you redraw this diagram. So from point A I will say C1 and C2. So this is my C1 and C2 appears to be connected in series with that. So this is C1, this is C2. My C3 and C1 both are connected to point A. So this is how you can draw your C3, and then your C3 and plate of C2 is connected to point B. So this is how you can actually break this particular diagram. Now this diagram which has been given a bit complicated, you have simplified it and we have seen that this is how we can write capacitance, but there is one more thing which you have to be very careful when you have to do. That is what? That C1 which is given over here, okay, that C1 which you have written, you need to understand that its area which you will consider this much, which is A by 2. So this area will also be A by 2. If you are separating your C1 and C2, remember the separation distance is not going to be D, it is going to be this. So what I am going to do for your convenience, C1, I will write that for C1 your area is A by 2 and your separation distance is D by 2. Similarly, when you write for C2, your area is A by 2, your separation distance is D by 2, and you also have a dielectric constant, so which I have also written over there. So you people should not make mistake that this C2 is having a dielectric in it, because then its value will be different. For C3, when we talk about, the area is A by 2, the separation distance is D, and here also you don't have any dielectric. What you need to do when you solve this question for C equivalent, the value of C equivalent, definitely first you have to solve for these two, because for me C1 and C2 appear to be in series. Capacitor in series, the formula which you will use is the one where you take reciprocal of C1 and C2. So I will recommend that you can directly do what? That C equivalent value will be C1 into C2 upon C1 plus C2. Yeah? We have the value of C1. So I will plug the value of C1. C1 is epsilon naught A by 2 and this is D by 2. C2 is, it is C1 into C2, so I will say C2 is epsilon naught A by 2 D by 2, but K will also be there in case of C2. Denominator when you write epsilon naught A by 2 D by 2 plus epsilon naught A by 2 K and D by 2. Okay. Calculation is the only challenge which we are going to face in this particular question, and if you do your calculation correctly, I think you would be able to get the correct answer. Now let me show you what you can do. In the above part, you can actually, you can cancel 2 and 2, so this 2 and 2 we will simply cut it. Now C equivalent when I am writing, be very careful, it is epsilon naught A and D and there is a square of it, and you can say there is K. Denominator, it is, you can take D common and you can say that epsilon naught A plus epsilon naught A K. Okay, so in this case, if you take epsilon naught A by D the whole square, yeah, I hope you can see this calculation, and here you can take the value of epsilon naught A by D common, so inside it will be 1 plus K. You also have K over here. Yeah guys, now what we can do, you can see that this and this will get cancelled, so we are getting a value of C equivalent, which I will write it here for you, that C equivalent which I am getting for C1 and C2, it appears to be epsilon naught A by D K over 1 plus K. Yeah, so this is how it appears to be. 1 plus K or K plus 1, whatever you want to write, it is correct. Question is still not complete because we have to see that C3 is also given, and C3 is something which you can write that C3 is epsilon naught. So epsilon naught I have written, it is no dielectric, area is A by 2, so it will be look like this. Now this C equivalent which you have calculated and this one, these two are in parallel with each other. Parallel means I am simply going to add these two. So what I am going to show you, I'll use space over here, that if I say that my final answer for C equivalent will be the sum of epsilon naught A, this is by D, and this is K, 1 plus K, plus epsilon naught A by 2D. This is how this appears to be, but if you simplify it, because this is how your C equivalent will look like, what I can do, if I take epsilon naught A by D common, inside it will be K, 1 plus K plus 1 by 2. So this is how we are going to get the C equivalent part. This is the simplified version, but let me show you when you have to comment on C equivalent, the C equivalent value we have got it. But there is also K equivalent which you people have to answer. So K equivalent you can do what? You can further simplify this. So I will keep my epsilon naught A by D as it is, and when you solve this particular part, which you can write 2, 1 plus K, you can say this is 2K plus 1 plus K. So your C equivalent can be written as epsilon naught A by D. This is 2K plus K will be 3K plus 1 over 1 plus K. This is what the final answer appears to be, and people are wondering that we got the C equivalent value over here. let me tell you that when you solve for C equivalent, the part which you have over here consists of K. This is going to be, this is 2 also here, which I missed. I will write it over here. 3K plus 1 and 2, 1 plus K. So you people can actually notice that your value which I have put inside the blue clouds, this is your K equivalent value if somebody has to mention. Yeah, this is one particular case. I have taken a bit complicated case, but you can see a various combination of capacitor can be given to you, and if you wanted to get to the right option, this is the way you can approach the numerical. So what you can do, you break your circuit into a simplified manner. So what I did first I have drawn my C1, C2, C3 separately. So don't try to visualize the entire system as one, break it into simplified manner, the way you can visualize it easily, and then you actually keep solving till the time you get the final answer. So first I have identified that my C1 and C2 looks in series to me. I have solved that part, and then I have solved the remaining part where the C3 appears to be parallel with it by using the formula, and when I keep on solving, I actually get my answer. So this is one particular thing which you need to understand when the question comes on capacitor, and if there is a dielectric which has been introduced, you people have to be very careful. So formula is a bit simple, but when it comes to the calculation, please don't make any such mistake for which you people have to pay the price by losing marks. Okay, wonderful. So guys, I think this question is clear to you. Then after that, I'll move to the next question. So let's see our next question, which is question number 14. Okay. It says find the value of a charge in C1, C2, C3. Now I know that this kind of a question you people have seen in regular syllabus also, but the point which you need to understand over here, there are two batteries which I can see, 10 volt and 20 volt, and there are 3 capacitors which has been arranged in a specific manner. What we need to do over here, we need to calculate the charge value and definitely find the value of charge on C1, C2, C3. What we need to understand that we have to approach this particular question in such a way that we should be able to save our time, because time is actually one crucial thing where we have to work on, and we can't spend a lot of time by solving it with an orthodox method and keep on trying and keep on doing this probability whether it is correct or not and finding potential difference for different capacitor, then going for the charge. But we will have a one particular method which we can use in the entrance, because entrance definitely no one bother about your steps. So I am going to reduce the steps. How I am going to reduce the steps, I am going to tell you. So you have to pay attention over here that what I am going to do, because this particular method you need to understand first that these 3 capacitor plates of C1, C2 and C3. As capacitor is something which you can see, it never allow a DC supply to pass through it, because there is a gap which is present between the 2 plates. They are not in direct contact with each other. So these 3 plates which I have made or connected in this particular irregular shape, whatever the charge is going to be on these plates, that charge value is going to be conserved. That is one thing which I can suggest. I don't know whether that Q1 value is more, Q2 value is less, or Q3 is more, Q3 is less. I don't bother about that particular part, because I know that whatever the charge which is present between the 3 plates, even if you change the value of voltage or anything in the circuit, that charge is going to be remain conserved between the 3 plates. And by that particular thing, what I can do, I can write one thing that my Q1, Q2 and Q3 is conserved, so that sum should be equal to 0. So on one plate you can add more charge, but definitely other 2 plates will give it, and if the other 2 plates are giving, so somehow that sum is not going to be changed. It is going to be remain conserved. After that, what I will do, once you visualize this, you try to visualize, okay, I'll keep it. This is the first step which I have done. After that, when I take my capacitor over here, 2 microfarad, this is the T junction point. You can remember this T word, whichever diagram you feel like that this T is present over there, you can use this particular method over there. There is C2 which is given as 2 microfarad. Okay. You can consider that this T junction, this particular potential, it is the highest potential. And on this side the potential is 0. That is one thing which you need to assume over there. You can see that C1, one of the plate of C1 is connected to 10 volt battery, which you can see it over here. A positive 10 volt battery terminal has been connected to C1. So you bring that 10 volt over here. So there should be no confusion about it. Similar thing you can do for capacitor 3, which has been connected to a positive 20 volt battery. So I will write my positive 20 volt over here. So this is what the entire information which I can actually take out from this particular question. Now after that, what we need to do, our aim is to calculate the charge. Let me tell you, if this particular technique, if you practice it 2, 3, 4, 5 times, you will be completely perfect in it, and you can use it in any given case which is given to you in the exam. Okay. Now what I can say, if I have to write the value of Q1, my Q1 is the charge which is present over here, my Q2 is the charge which is present over here, and Q3 is the charge which is present on my third plate. So I have assumed Q1, Q2, Q3 in such a manner that this is the charge which is present on the 3 different capacitors. If you remember the formula for Q, how do we write Q? Q is CV. Yeah, so charge can be written as CV. So if we have to write my Q1, I can say my value of C1, which is 2 microfarad multiplied by the voltage. Now potential difference between this is what? X minus 10. I've told you X can be considered as a high potential. So high potential minus low potential. That is what I've written, the potential difference. Okay. After writing that particular point, plus then your Q2 value, which I'm going to write, and for that first I need my capacitance, which is 2 microfarad. So again your potential difference is X minus 0. So you can actually visualize, okay, the potential difference has been written between the 2 points. So I have subtracted high potential, low potential value, and I have parked it over there. After that, when I see my Q3, which I can see the value of Q3 is given as 1 microfarad. So let's write it as 1. Potential difference when I write between the 2 points, X and plus 20, it can be X is high potential minus the lower potential, and this sum should be equal to 0. So everywhere what we have done, we have considered X as a high potential. That is what we have assumed, because by writing this equation I would be able to calculate my value of X. And let me tell you, the moment we calculate the value of X, you will get a clear idea that with whichever voltage has been written, whether you were doing it right or wrong. So it doesn't matter in that particular case. So what we can do, 2x minus 20 plus 2x, 2 into 0 will be 0. This is x minus 20, the sum should be equal to 0. I can see this value of 2x and x I can add, and I can write it as 5x, and then minus 40, if I take it to the other side, it will appear to be plus 40. I am able to see that x is 40 by 5, which appears to be 8 volt. So somehow by this particular method I am able to calculate that what will be the potential at point X. Once I get this, guys, I think my question is done, because my aim is to what? My aim is to calculate the charge. Now what I am going to do, I will say Q1 when I have to calculate, I take help of C1 and the potential difference between the point where the C1 is present between the 2 points, which is X minus 10, but now you know that we have calculated X. So when you compare that, okay, X is something 8 volt, so it is 10 minus 8, because 10 is higher. So you people will do 10 minus 8, which will give you 2 volt. Capacitance value is what? 2 microfarad, 2 microfarad. Capacitance value is 2 microfarad multiplied by 2 volt, which will simply give you 4, but remember it is 4 what? Microcoulomb. So I have not converted any value before, so I am simply writing when I am going to multiply this 2 with 2, the microfarad I am writing for capacitance, so my answer will also come out to be microcoulomb. Yeah, you have to be very careful with that, so please don't write 4 coulomb for that particular part. Now look here, similarly if I have to calculate the value of Q2, for Q2 you people will see that capacitance is given as 2 microfarad and it is 8 minus 0, which will be 8 volt, which will give you 16 microcoulomb. So we are able to calculate the value of Q2 also. If we go for Q3, the capacitance over there is 1 microfarad, the potential difference has been given is 20 minus 8, which will be 12 volt, and multiplying this will give you 12 microcoulomb. So guys, I think we have the value of charge for all 3 capacitors, and this is actually one particular strategy which you can adopt to solve question on capacitor. Usually there are different methods, but this is one particular method which you can follow to solve this capacitance questions very quickly. Yeah, I have taken good amount of time so that I should be able to explain things to you clearly, but when it comes to the exam, you people can actually reduce time in doing all this calculation. Yeah, so there's no need to redraw the diagram, break it. You can do everything the moment you see any particular circuit where you can relate with this particular T junction, and you can go with this particular approach where you can directly get the answer for your charges for all 3 capacitors, and you can give it to the and you can select accordingly your correct option. Yeah, so I hope things are very clear to everyone till now. We have solved 14 questions. Okay, let's move on to the next question, which is 15 question, and I think this is the last question which I'm going to take in this particular part. But first, let's see what exactly the question says. Here the question says a charged particle Q is shot towards another charged particle Q, which is fixed with a speed v. It approaches Q up to a closest distance r and then returns. Okay, if Q were given a speed to v, the closest distance of approach would be. Okay, now one thing which you need to understand whenever you have any such kind of equation, first of all try to figure out that what exactly is given to you and whether we can build any relation based on that particular equation. Now when you actually project this charge, definitely it will have some kind of a kinetic energy. The moment it will stop somewhere, this is the point where it stops, what will happen? The entire kinetic energy has been converted into potential energy, and that is the one reason that it is actually going to stop at that particular point. Okay, so I think I can say that my kinetic energy is going to be completely converted into my potential energy, where the charge is going to be stopped for a moment and then it will start moving in the same reverse direction. Kinetic energy is something which you can write as half mv square. Potential energy, now definitely potential energy you can write it as mgh because this is part of electrostatic. In electrostatic, your potential energy formula, I hope you remember, it is K Q1 Q2 by R, where the value of K can be written as 1 by 4 pi epsilon naught. Yeah, so I am going to take help of this particular formula. So I am writing K is actually a constant, so we can write it as K. The charge 1 which is involved is capital Q and small q divided by the R. The small r value where the charge is going to be stopped for a moment and then it is going to be moved back. Okay, from this what I need to do, is it a way that I can derive a relation between r and the velocity? Yes, because that is what has been given. In the question it says that when velocity is going to be doubled, how exactly the distance of approach, which is written as r, is going to be changed. So I need to derive one particular relation between these two quantities. The moment I write the formula, I can see both the quantity in my equation. What do you need to do? You have to make r as your subject. So I will take r to the other side. This is k, this is q, this is q, and then what you can do, you can take the value of 2 here and your m V square will come down. Okay. So when I make R as my subject, I have written mv square down and I have written 2 up. So this is what it looked like. Now there is one thing which you need to understand. When I look at this entire question, in this question my k is a constant, it is not going to be changed. The two charges which are involved, even if you are changing the velocity, those charges are also not going to be changed. So that q small and q capital both are same or constant, which are not going to be changed when the condition is going to be changed. Mass of charges will also be the one which you have projected, it is the same. So what we need to understand, that if all these quantities are constant, you better derive a relation that your R is written as this way. Removing a proportionally sign, you have to introduce some constant, we know that. So here what I have done, I have removed the equal to sign and I have introduced a proportionally sign. It's vice versa. Makes sense. Now I can simply say that if I have to calculate my new approach, distance of approach, I can say that is R dash, I'm going to calculate, and the relation which is given as this. So what we can do, your question says that velocity has been doubled. So what you can do, you can plug this velocity as 2v and take square of it, because that is what you have derived over here. So whatever the relation you have derived, you will go according to that. So when you do that, your R dash is directly proportional to 1 by 4v square. Now you know that your 1 by v square is nothing, it can be plugged as R, and this will be the new distance of approach which you are going to get. So when you have increased your velocity by twice, the distance of approach is 1 by 4th of your initial distance. So the correct option in this case appears to be option number D, which is my correct option. Yeah? Okay. So guys, there are somewhere around 15 questions I have done on electrostatic, and definitely you can practice similar kind of a question in this particular session. You can solve multiple worksheets, but the concepts which are important, the concept where you can reduce time, that is those concepts I have explained you. There are few strategies which I have explained you, which definitely you would be able to adopt if you practice those particular strategy n number of times, okay? Or in this duration we have 20 days remaining, now it is 18. So practice those type of questions 3 to 4 times, so that you should have an habit of using that particular. Because if there is any quantity which has been changed, sign convention which has been changed, you should be able to approach that particular question according to the requirement which is given in the question. Yeah, because let me tell you that every single question which we are practicing, even if there is some small change is introduced by the examiner, your entire thought process you need to change. Yeah, you will attack that particular problem according to the requirement which has been given by the examiner. Okay, so don't go into the exam hall under the impression that you have already seen that question. Even if you have seen that question, I would suggest you read that question completely again, so that there should be no tricky part involved in that particular question. Yeah, so guys, thank you for today. This is our session 2. We'll see you in the next session with our topic electric current. Thank you.